Hey everyone, welcome to the NumPy Fundamentals course. My name's Derek and I'm here to be your instructor throughout this entire program. I've helped thousands of students online learn more about Python, NumPy, and many more topics. I've always had a passion for coding and I love helping others learn. That's why I'm very thankful for the opportunity to post free content like this course to places like Udemy and YouTube. So that's why I'm very excited for you to learn how to use NumPy. This course will assume that you've used a little bit of Python, but if you haven't, don't worry. I'll include a brief section 2, which will have all the basics on how we can start using Python. If you're already comfortable with that, feel free to skip to section 3. If you start in the NumPy section of this course, or once you finish the Python section, you may find that the NumPy lessons happen very quickly. This is on purpose. This is because if you just need to see a topic once to understand it, I don't want to waste your time by going over more examples. However, I don't want to leave anyone behind either. So that's why there's an optional practice video after every single one of the lessons. So if you need more practice with any given lesson, jump over to the practice video and try to use the concept more. Thank you again for choosing my course. I'll see you in the next video. Hey everyone, welcome to the NumPy section of this course. You probably already know a few use cases of NumPy, but we'll cover a few briefly. The first reason why you might want to use NumPy arrays is to increase the speed of your Python scripts. Python inherently is pretty slow using a for loop. That's why NumPy comes in and can vectorize the entire operation and make it much quicker. Don't worry if you don't understand all that right now, we'll talk about it in the course. But in short, this vectorization means that we take up less memory in our system. When we're taking up less memory, we can do operations a lot quicker. To get started using NumPy, we'll have to first install it, so go ahead and open up a terminal. I'll jump over to my text editor, which has my terminal at the bottom. And to install NumPy, we need to use the package manager. The package manager for Python is pip. So I'll run pip3 and then install NumPy. I already have this downloaded, so that's why I get the requirement already satisfied. But if you don't have NumPy, this should download it and install it for you. Once you have that, you're ready to begin. I'll see you in the first lesson. Hey everyone, let's start talking about NumPy arrays, how we can create them, and the important attributes associated to them. Let's get started. You should already have NumPy installed, but if you don't, remember that the command is pip3 install NumPy. Assuming that you have it installed, we'll import NumPy as np. Now every time that we want to reference a NumPy function, we'll use this np first. The main purpose of NumPy is to use the multi-dimensional arrays. Let's create an array now. We'll say array A. We'll reference the NumPy package by typing np, and then we'll use the method array. We'll put parentheses, and this function takes in one argument to create an array. So that means we need to pass one sequence to this function. A sequence in Python is just something like a list or a string. We'll use a list for this example. We'll create a simple list and we'll pass in 1, 2, 3, 4, 5. Now if we drop down and type in print array A, we'll save the file and open up a terminal. Executing the file using Python 3, and the name of mine is NumPy arrays lesson.py. We see that we returned a simple array using NumPy. But this looks a lot like the list that we passed to it in the first place. Right now, we may be tempted to just drop down and say print list of 1 through 5. When we save and execute this, we should get a return that looks very similar, which we do. So what's the point of using NumPy to do this if we can just create lists to contain the values that we want? The first reason why we might want to use the NumPy array is that the operations using NumPy arrays are a lot faster than a Python list. This is because a NumPy array is homogeneous, and that just means that it has one type of data in it. If we wanted to add an element of a different data type to this list, we could. So we'll pass in my name, Derek. When we save and execute this, we should have no problems, which we don't. This is because Python is a dynamically typed language, and that just means that we don't have to explicitly state the data type of each variable whenever we create it. This is an awesome feature if you're dealing with heterogeneous data types because it's built directly into Python. But if you're not working with heterogeneous data types and you have a homogeneous data set, it actually slows you down having that ability. There's a long explanation of why this is, but in short, Python needs more data whenever we don't explicitly state the data type. NumPy arrays don't require this extra memory because they're a homogeneous data type, and that just means that the things that we put into a NumPy array can have operations performed on them much quicker. If we were to add that string to our NumPy array, we might get some unexpected behavior. So let's see what happens when we add Derek to our NumPy array. We'll save the file and execute. It may look like that we get the result that we want. However, if you look closer, it's not the result that we expected. Instead of having 5 numbers and a string, we've turned all of these into a string type. This likely isn't what you want to do, however this is how NumPy handles the situation. Each of these elements can be a string, so that's why NumPy creates a homogeneous array of all strings. The string there cannot be an integer value, that's why the entire list can be of integer data type. If you're working with heterogeneous data, go ahead and stick with the Python list. Let's just work with integers for this example, so we'll take out this string and save our file. The next important note about NumPy arrays is that they have dimensions. We can see these dimensions whenever we access the NumPy array attribute shape. So let's look at the dimensions of this first array. We'll drop down and say print array A. We'll access attributes using a period, and then we'll say shape. We'll execute, and we see that we returned a tuple with only a 5. A NumPy array shape will have a tuple where the first value represents the rows and the second value represents the columns. We only have a one-dimensional array here of the length 5. So this has a shape of 1, 5. We don't see that here because the 1 isn't explicitly stated, but let's see how we can make a multi-dimensional array. We'll drop down and say array B is equal to NumPy.array parentheses, and now we need to be sure to only pass one argument to our NumPy array function. We may be tempted to create 2 lists like this, 1, 2, 3, 4, 5, and then a second list of the same values. However, in this case, we're passing 2 arguments to our NumPy array function. We have the first argument here, and then the comma denotes a new argument, so the second argument would be here. Therefore, we need to put these all into one list value and create one argument. We can do that with the second set of square brackets. So we'll include all of these in one set of square brackets. Now we have one argument that we're passing to the NumPy array. This is just a Python nested list, and it will create a 2-dimensional array of the length 5. We'll see that array now. So we'll say array B, and we'll print that to our terminal. So now, like I said, we have 2 rows, and each row has 5 in the length. If we were to change this to print the shape of this array, we should be returned a 2, 5 in a tuple, which is exactly what we get. What we should take away from this video is that a NumPy array has a homogeneous data type, and that just means that every element is the same type in the array. Each array also has a shape, and we can access the shape with the shape attribute, and it's returned to us in a tuple, where the first number is the number of rows and the second is the number of columns. If you understand how to create NumPy arrays and feel comfortable with the shape of an array, then feel free to skip the next project video. If you would like more practice, we'll cover it in that one. I'll see you in the next video. Hey everyone, welcome to the optional NumPy arrays project video. In this one, we'll cover how we can make arrays of different shapes and how we can view the shapes of those NumPy arrays. Let's jump right in. I already have NumPy imported, so let's begin by looking at how we can make arrays of different shapes. Let's start off with an array of the shape 3 by 3. So our goal is to make an array of 3 by 3. We'll do this using integer values. We know that the first number is the number of rows in the array, and the second number is the number of columns. The number of columns just refers to the length of the sequence that we pass to the array function. The number of rows is just how many sequences we pass. If we wanted to create an array of the shape 3 by 3, that would mean that we would need 3 sequences, each of the length 3. Let's do this now. So let's say sequence A is equal to a list of 1, 2, 3. Then sequence B will be equal to a list of the same length. So we'll say this one will be 4, 5, 6. And then sequence C will be 7, 8, 9. Now to create the array, we'll say array ABC is equal to the NumPy function array, how we did in the last video. And now we need to create one object that we want to pass to this array function. You may be tempted to type in sequence A and then sequence B and do this for each of the lists, but this is passing 3 arguments to the array function. Instead, we need to create one list that has all these other lists nested inside of it. We'll do this using square brackets. And now we have one object with 3 nested lists. By doing this, we have one list, but we have 3 lists nested inside of it. Now we'll drop down and say print array ABC, and then use the shape attribute to return the shape. We'll save the file. I'll open up a terminal, and then we'll say Python 3 NumPy arrays project.py to execute it. And we give back the tuple that contains the shape. We have 3 rows and 3 columns. If we wanted to create an array of the shape 4 by 3, we could just potentially add another sequence. So let's say sequence D is equal to 10, 11, and 12. Now if we were to add this into the last entry into our nested list, we should be returned a tuple of 4, 3, which is what we get. Each of these lists only contain integer values though. So what do you think happens whenever we create a float inside one of these lists? We'll do this with the sequence D. So to create a float, we'll just use decimal numbers. So we have 10.5, 11.5, and 12.5. We'll save the file. And now remember that a NumPy array can only have one data type. So if one list has float numbers, that means the NumPy array will then use floats for every other value in the array. This is just because with an integer value, you can accurately display it as a float number as well and not lose any information. We'll see this return, so we'll take away the shape attribute and we'll just print array ABC. Now we see that each list, although they're integer values, are converted to the data type of a float number. To see if you've mastered this concept, see if you can create an array of the shape 5, 2. However, instead of creating each sequence on a new line, see if you can code just one line of code and create that array. To get you started, it would look something like this. We would say array D is equal to a NumPy array. We'll use parentheses, and then we would need 2 square brackets to begin with. After this, I'll let you figure out. If you need any help, be sure to let me know. I'll see you in the next lesson. Hey everyone, welcome to the next lecture. In this one, we'll talk about how we can start indexing our NumPy arrays and how we can reshape them. Let's get started. We'll go ahead and import NumPy as NP. Now let's make a simple array. We'll say array A is equal to a NumPy array, and we'll give this one the shape of 2, 3. So we'll say 1, 2, 3, and then 4, 5, 6. So now we should know that this one has a shape of a tuple 2, 3 because it has 2 rows and 3 columns. We'll go ahead and verify this. So we'll print array A dot shape. We'll save our file and open up a command prompt or a terminal. And I'll type Python 3 NumPy indexing lesson 1.py to execute. And we see that we get that tuple of 2, 3. Now let's talk about a new attribute to our NumPy arrays. Every NumPy array has a size attribute. The size attribute is just the number of columns times the number of rows. So since we have 2 rows and 3 columns in this array, that means we have 2 times 3, which is equal to 6. We can see this in our terminal, so we'll say array A dot size and print to our terminal. But what does the size attribute mean for us? If we reshape an array, the sizes must be the same before and after we reshape it. Let's go ahead and make a new array. We'll say array B, and we'll reshape this from array A. We can use the method reshape, and this is a function that takes 2 arguments. The first argument is the number of rows, and the second is the number of columns. So since we have a size of 6, we only have a few options. We could reshape this to 1 and 6, so 1 times 6 would still give us the size of 6, or we could reshape this to 3 and 2. If we were to try to reshape this to 3 and 3, we would get back an error because the sizes are inconsistent. So we'll leave it as 2, and then we'll print array B. We'll save this and execute it. And now our array has 3 rows and 2 columns, but maintains the size of 6. In this example, all we've done is switch the number of rows with the number of columns, and that's a transpose. In NumPy, we could have just said capital T. We'll save this, and we should get the same result that we got before, which is exactly what we get. So now we should know how we can reshape our arrays and how we can transpose them. Let's talk about how we can pull out specific values using indexing. In NumPy, indexing is done by using integer values in square brackets. We'll talk through a couple examples. So we'll say print array B. So we're using this array that we just created of shape 3, 2. We'll use those square brackets. And let's say that we wanted to pull 1 row of information from our NumPy array. We can do this by using the index position of that row. So in our example, 1, 4 is in the 0 index position because NumPy starts at 0, 2, 5 is in the first index position, and 3, 6 is in the second. So if we wanted to pull the first row, 1, 4, we could just put a 0 here, save our script, and then I'll comment this one out, that way we don't get it confused, and print this. Now we're returned only the first row in our NumPy array. Now let's look at how we can return an entire column. You're essentially wanting every row value, but only at a certain position. To do this, we could say print array B. And to specify every row in Python, we can use a colon. So we're saying every row, but we only want a certain column. So we need to specify the position of that column. In our example, we only have 0 and 1 because it's a length of 2. So in our example, let's get the second column or the first index column. We'll use a 1. We'll save and print this. And now we're returned 4, 5, 6, which was just every value in that second column. But what if we only wanted to pull out one specific value? We'll do this by saying print array B, square brackets, and instead of using a colon for every row, we'll say the first row or the 0 index row and the first value. So 0, 0. We'll save this and we should be returned a 1, which is what we get. So now we should know how we can index values out of an array. If you feel comfortable with this and also with transposing and reshaping arrays, then feel free to skip the next optional project. If you would like more practice, I'll see you then. Hey everyone, welcome to the optional project video for NumPy reshaping and indexing. Let's get started. We already have NumPy imported, so let's go ahead and make that sample array from the last video. But this time, instead of using the size 6, let's try to use the size of 16. So we'll say NumPy array as a function, 2 square brackets, and then 1 through 4, 5 through 8, 9 through 12, and then 13 through 16. So now we have an array of the size 16. Let's think about how many different ways we could reshape this array. We'll say array B is equal to array A. We'll use that reshape method as a function. And now let's go over the different shapes that we can make this array. We could do 1 and 16. We could do 2 and 8. 4 and 4 is already the shape of our array. We could do 8 and 2. And then we could do 16 and 1. 1 and 16 and 16 and 1 are the same thing because they're only one dimensional along one axis. So you just have the values listed out 1 through 16. So let's make this into 2 rows and 8 columns. To do this, we'll say 2 and 8. Then we'll print array B. We'll open a command prompt or a terminal, and we'll execute the script using Python 3 NumPy indexing project.py. So we get 2 rows with each one having a length of 8. What do you think happens if we transpose the original array A? If we say array C is equal to array A, and then we'll use that method transpose, which is a capital T, and then we'll print array C. We'll execute this, and now we get the new array that we just transposed. Each of the rows values now go into the columns, and each of the columns values go into each row. If you were to transpose this array again, then you would go back to the original array. We can see this by adding the transpose method to our print array, and then we'll execute again. Now we return the array back to the original form by transposing it twice. Now let's talk about indexing values out. So we already saw that we can index values out using square brackets. We'll say print array C and pass in those square brackets. Think about for a moment how we could return 2 rows from our NumPy array. Let's say that we wanted the first one and the second one. We already know how we can return the first one. We can use a 0. But now, if we wanted to return the second one as well, we couldn't just put a 1 here. Because now we're returning one value. We're returning the first row and the second value in that row. Instead, we could do this. We could put a comma here and then type array C again. The print function can take multiple arguments, so we're just indexing the same array twice, pulling 2 rows. We'll print this, and now we've returned both of those rows. NumPy also supports negative indexing just like Python. So let's say that we wanted to pull out this 4 value in our NumPy array. To do that, we could say print, and now this one was the first array, so array A, we'll pass that here, array A. It's in the first row, so we could say a 0 for that value, and to pull out the last value in that row, we could just say -1. That's because we're counting backwards from the end, so -1 would be here. We'll print this, and we should be returned a 4, which is what we get. If you wanted the last row in the last column, you could change this from 0 to -1. So now we should be returned 16. We'll print this. And the same slicing methods that are available in Python, we can use in our NumPy array as well. We'll talk about more advanced indexing methods in the upcoming videos. However, for this project, let's see if you can return the second column using negative indexing. Once you get that second column, see if you can do a separate operation to pull out the number 10. To get you started, to pull out the second column using negative indexing, we would start with array A, square brackets, and we want a column value, so we want every row value at a certain position. Then I'll let you figure out the rest. If you have any questions or comments, please let me know and I'll try to help you out. I'll see you in the next lesson. Hey everyone, welcome to the next lesson. In this one, we'll look at some defaults that we can use when making NumPy arrays. Let's get started. Here in our text editor, I already have array A, which is our typical 1, 2, 3, 4, 5, 6 array that has 2 rows and 3 columns. We already know that when we create an array that NumPy will assign a default data type to the array. It's doing this based on the elements within the array and it tries to find the one that best fits the information. However, we can override this default by using a different argument in our array creation. This argument that we can use is called dtype, and we can set this equal to whatever data type we want our array to be in. So for this example, we've already seen that the default is to use an integer value because all of these are ints. What if we wanted to change this default to use a float? Here on the dtype argument, we could just use float. Now when we print array A, all the values in this array will be in a float instead of the default integer that NumPy would assign to it. We'll see this by opening up a command prompt or a terminal, and we'll execute the file. So this one is default arrays lesson.py. We see now that the information is returned to us as float values instead of the default integer. We can use most of the Python built-in data types, and also NumPy provides us some new data types that we can use as well. So now we know how to override the default data type whenever we create an array. Let's look at a few more ways that we can create these arrays. If we wanted to create an array of just 0 values, so we might want to do this if we're just creating a blank matrix and want to add values to it later, we could say array B is equal to NumPy. We'll use the method zeros. This is a function, so we'll put parentheses. And this takes one argument, which is the tuple, which is the shape of the array that you want to create. If we wanted to create a 3 by 3 matrix of just 0 values, we could say 3 rows and 3 columns. Now we can print array B, and we should have that blank matrix full of 0 values, which is what we get. If we wanted to do the same thing, but instead of zeros, we wanted ones, we could say array C is equal to NumPy ones, and then pass in the same shape. So 3 and 3. Then we can print array C. This time, instead of zeros, we get just ones. If you wanted to assign a different number other than 1 or 0, we could use a separate function. We could say array D is equal to the NumPy method full. And now this one takes 2 arguments. The first being the shape of the matrix, so we'll say 3 by 3. And if we wanted the number to be a 5, we could just put 5 as the second argument. We'll print array D, and now we should have a matrix of 3 by 3 with the number 5. Lastly, let's say we wanted to create a sample array that has random numbers in it to test out some function or method and see if it works. We can do this. We'll say array E is equal to NumPy.random as a function, and then this one takes the tuple of the shape as well. So if we wanted a 3 by 4, we would say 3 by 4, and then we could print array E. When we get the result, we see we have a random number in each of the element slots of our array. Depending on the operations you want to do on your data, using these techniques may be quicker than using the array creation methods before. There's not a lot to talk about with these creation methods other than how to use them. So in the optional project, we won't deal with that. If you want to do the optional project this time, we'll work with the data types of the array creation here. If you feel comfortable with the data types available and you understand how to create arrays, then feel free to skip that project. I'll see you in the next lesson. Hey everyone, welcome to the optional practice video for the default array lesson. In this one, we'll be talking about data types. Let's jump right in. Here in my Python script, I already have NumPy imported, and I have a few notes about the NumPy data types. We see that we have integer values, we have unsigned integers, which are just positive integer values, and then we have floats. There's a few more that aren't listed here, but these are the ones that we'll deal with the most, mainly integers and floats. The practical understanding of the bit sizes just determines how big or how small your number can be. We see that the integer 16 data type can only effectively specify numbers between these two values. Most of the time you'll be using data types that have the 64-bit size, but let's see what happens when we accidentally overflow a NumPy data type. We'll drop down and create an array. So array A is equal to a NumPy array, and then we'll pass in a list of 32,766, 32,767, and then 32,768. Notice how this number is one above the maximum specification for the integer 16 data type. We'll print array A, and we should have no problem because we know that NumPy will use a data type that accurately describes every element in that array. To print, we'll say python3 and default arrays project.py. We see that we have no problem. The array is just how we specified in this line of code. Now let's use a new attribute. We can see the D type of an array with the attribute .dtype. We'll put that in and execute again. And we get back that NumPy has assigned this array a data type of int64. Since all of our numbers in this array fall between these two huge numbers, we have no problem. But let's see what happens when we change the data type to an int16. Remember, we can do that by setting a keyword argument of dtype equal to numpy.int16. We'll save and execute this. We see that we've successfully changed it to an int16, and now we'll take away this dtype attribute. Executing again. When we get back the result, we see that we have some unexpected behavior. We now have a negative 32,768, when before we only typed in 32,768 positive. This is because we've overflowed the data type and we only have the ability to do these numbers using that data type. Most of the time you'll never have to worry about this, and in fact we kind of have to go out of our way to see this happen. That's because NumPy will assign a default data type that will accurately represent your data most of the time. However, it's important to know that we could overflow our data type. So if you start getting unexpected results, check your data type and then make a decision from there. We haven't seen the unsigned data type yet, so let's do that now. We'll drop down and say array B will equal numpy.array, and then let's make a list of -1, 0, and 1. We'll set this D type equal to MP unsigned integer 16. Then we'll print array B. Now when we execute this, we have a signed integer here with the -1, but we have an unsigned integer data type. So what do you think happens? And now we see we get some very unexpected behavior because we return 65,535 when we put in -1. That's because our unsigned integer data type only takes positive values. So why would you ever want to use it? We might want to use the unsigned integer data type because we have very large numbers that we can't represent with the regular integer data type. That's because all the bit space on the unsigned integers goes into the positive. I don't even know how to begin pronouncing this number, so most of the time you'll never have to worry about this. However, if you are working with extremely large numbers, the data types would be something that you would need to consider. The last note here is that when we call numpy.float, we're just calling the same float data type that's represented in Python. So unless you're working with extremely precise float numbers, calling the mp.float or just the regular float will be fine for your purposes. I know this was a short practice video and there's not really a practice problem for it. However, there's a few key takeaways that we can learn from this video. The first is that we are able to overflow a NumPy data type, and whenever this happens, we can get unexpected behavior. The second takeaway is hopefully now we understand why an int32 and an int64 are different values, and it's just because of the bit size allocation in the memory. If you have any questions or comments, as always, please let me know. I'll see you in the next lecture. Hey everyone, welcome to the next lecture. In this one, we'll be covering advanced indexing methods. Let's get started. Here in our text editor, we already have NumPy imported and we have 5 lists created. Each of these will be one row in our NumPy array. Let's go ahead and see that array. We'll execute the file by saying python3 and advanced indexing lesson.py. So we see that we have a 5x5 array of 1 through 25. I mentioned it briefly in the last indexing video, but let's see how we can use a Python slice to index out data from our NumPy array. Then we'll say print. We'll index on that array. So we need the name of the array, which is test data. To do the indexing, we'll use those square brackets again. And now let's say that we wanted to pull out every third and fourth value from every row. So this would be 3 and 4, 8 and 9, and so on. For us to say every row, we can use a colon. And now we need to access those values by their index position. So remember, to do a slice in Python, we start with the starting step, we go to the ending value, and then the last number will be the step size. So for us to pull out this value and this value, we need to do 0, 1, 2. So we'll start with 2. We need to go 1 past our ending value. So let's say 4, which would be this value. And we have a step size of 1. We'll save this and execute it. And now we see how we can return a slice of a NumPy array. So now let's talk about how we can reverse these values if we wanted to. We only talked about this in the project video, but let's do a negative index. So to do a negative index here, let's say that we wanted the same values that we returned here, but we want them reversed. We can do this the same way. So we'll say test data, square brackets, and then we want every row. But now using negative indexing, let's start at -2, we'll end at -4, and then a step size will be -1. So negative indexing in Python just starts at the last element and goes backwards. Using this code as an example, we'll scroll up to this array. So we're saying go to the -2 position, which would be 4 in the first row, continue with a step size of -1 until you reach the -4 element. So we're saying start at 4 and continue until you reach 2. However, we know that the 2 is not included in our slice, so we only return 4 and 3. We'll save this, and then we'll execute to make sure that we get the result that we want. And we do. So now we know how we can use the Python features of a slice and negative index on our arrays. Let's see how we can use the NumPy package to do Boolean indexing. A Boolean is just a true or false value. So we're using true and false values to index out specific values from our array. How we do this is we create a separate array of the same size as the array that we want to index. In this separate matrix, we'll have true and false values. Let's see how we can make one of these now. We'll say our matrix name is greater than 5, and this will be test data. So we're referencing this NumPy array here, and then we'll use some kind of conditional statement. So our array is named greater than 5, so let's say that our condition is greater than 5. Then we'll drop down and say print greater than 5. So this will be a separate array of the same size as this array, and it will have true and false values where this condition is true and false. We'll print this and see that array. Once we print that array, we see that all the values that were less than or equal to 5 are false and everything else is true. So now we can use this true and false array to index out the values from the original array. We'll do this by saying print, and then the original array was test data. We'll index using square brackets again, and we can just use this new array to index out those values. We'll save this and print. And now we get back a one-dimensional array that only has elements that return true against this conditional. Let's take this one step farther. What if you don't want a one-dimensional array? What if you want to retain the shape of the array that you had previous and still apply a logic condition? We'll do this using the where method. How we apply this method is we'll create another array. So we'll say drop under 5 array, and this will be np.where. So we're saying the where method from the NumPy package. We'll pass in a conditional. So ours was test data is greater than 5. The first argument after this is what value you want whenever this returns true. So we'll say the value of the test data array. And then the second value is the false return. So let's just say 0 where this condition is not true. Now we'll print drop under 5 array. We'll execute this. And now we have a new matrix where all the values under 5 have been replaced by the number that we denoted here. And lastly, I want to show you one more method. Let's say you have multiple conditions that you want to apply to your NumPy array. We'll drop down, and the function we'll use here is logical and. So let's say this array will be drop under 5 and over 20. I forgot an underscore here. And this will be a NumPy logical and function where we pass 2 conditions as the first 2 arguments. So we'll say test data is over 5 and test data under 20. Now we'll print drop under 5 and over 20 array. This will give us back a true and false matrix that we saw before. We'll print this, and now we have falses here, and we have falses here. So these values were under 5, so they didn't meet this condition. And then these values were over 20, so they didn't meet this condition. Now that we have this true and false matrix, we can just apply this to the test data array and use square brackets in the same way that we did before. When we execute this, we should see another one-dimensional array that has only those values. If you already have a good grasp on Python slices and negative indexing, then the key takeaways of this video are how to use the where method, the logical and method, and how we can use a true and false matrix to pull out values using Boolean indexing. I know we covered these 3 new methods very quickly, so if you would like more practice, the optional practice video is coming up next. If you feel comfortable with these, I'll see you in the next lecture. Hey everyone, welcome to the optional practice video for advanced indexing. Let's get started. Here in our text editor, I already have NumPy imported. Let's look at a new way how we can create a sample array. We'll say array A is equal to the NumPy method arrange. This takes in 3 arguments. So the first one is the starting position. We'll say 0, and then we'll end with 100, and we'll have a step size of 5. Now let's print array A. We'll open up a command prompt or a terminal and say Python 3 advanced indexing practice.py. Now we see that we have a one-dimensional array starting at 0 and ending at 95 with a step size of 5. Let's say print array A dot size. So we'll get back the size of this, and we see the size is 20. So let's go ahead and reshape this. We'll say array A reshape is equal to array A dot reshape, and then let's say 4 rows and 5 columns. We'll save this, and then we'll print array A reshape and run this to our terminal. Let's use this sample array of shape 4x5 for this video. First, let's get some more practice using negative indexing. Let's say that we wanted to return every last value from each row of this array. We could say print, and then we'll call in that array. So array A reshape. We'll use square brackets to index. The colon denotes every row. And then if we want the last value in every row, all we need here is a -1. We'll save and print this. And we see that we get back a one-dimensional array of 20, 45, 70, and 95, which is just the last column in this array. This negative indexing is something built directly into Python. So anytime you have something that you can index, you're likely able to use negative indexing as well. Now let's do another example of Boolean indexing. We'll create a new variable. So we'll say array A, and then let's say this one is above 50. Remember that we call the array that we want to do the condition on first. So we'll say array A reshape, and this time let's do it in one line. So last time we created a true and false matrix on one line and then applied that matrix to the array on the second line. We can actually combine these into one Python line. We'll do this by saying array A reshape again. So we're indexing this with the same array as before, and then let's make the condition above 50. So in this one line, we're creating a true and false matrix here, and then using that true and false matrix to index this matrix here. Then we assign that to this variable name here. So let's print array A above 50. We'll execute this. And now we have all the values indexed out above 50. We can use any of the Python logical statements here. So this doesn't have to be greater than or less than. It could be not equal to, which would look something like this. It could be equal to, it could be greater than or equal to, and many more. We'll save this and execute it. So now we should include 50, which we do. But notice how we're only applying one conditional statement here. If we have multiple statements and need to do an AND or an OR logic, we would need to use a separate method. We could index this new array again, but notice that we're now indexing a one-dimensional array instead of the original 4x5. So let's do that now, and we'll use a Python slice to do this. We'll say print array A above 50. So this new one-dimensional array, which is right here, we'll index it, and then we're using a Python slice. So let's say we start at the first number, or the 0 index position, and now let's say that we want to go all the way through the array, but depending on this conditional, we may not know how long that is. we'll just say length of array A above 50, and then let's say that we want every other value. We'll do that using a 2 here. So this is just a Python slice starting at the first value and going all the way through the array. We're skipping every other value by using the 2 here. We'll save and print this. And now we're returned 50, 60, 70, 80, 90, which is just every other value of the array that we indexed. But we're doing this operation on a one-dimensional array. What if we have the old array, so this one here, and we wanted to take a slice on every single row in that array? We'll say slice of a row, and then we'll drop down and say print. This array was array A reshape, so we'll pass that in here. Array A reshape, square brackets to index. To do this over every row, we'll say a colon, and now we can just use another Python slice. We'll say 0 to 5 and skip every other value. We'll print this. And now we have a new array of the size 4 by 3. So we've gotten more practice using slices with this example and this example. We've looked at how to do a conditional statement again, and we've also looked at negative indexing again. We'll use that where method one more time. We'll say print, and then this one is numpy.where. We'll pass in the array. So array A reshape is greater than 50. Now remember, the first argument is the value that you want to have when true. So we'll say this is just equal to the array A reshape's value. And then for all the false values, we'll say -1. We'll print this and execute it. And now we have a new array where every value that is not above 50 gets the value of -1. So to use the where method effectively, we just need a condition, which is what we have here. We're saying where everything is above 50, then you need to put a true value. Our true value is just the value in the array already. And the last argument is just the false value. So where this condition returns false, put in this value. We'll talk about math operations in the next video, but we could do something like this. We'll say array A reshape, and then we can multiply all those values by 2. Now if we were to execute this again, we get a completely different array based off the values from the old array that we're using a function, and then we're returning a false value. I have 2 challenges for you on this project video. The first one is to take this array, the one that we created in the very beginning, and see if you can reverse each element within the row using negative indexing. So the result would be 20, 15, 10 in the first row, 45, 40, and 35 in the second row, and so on. The second challenge is to see if you can pull out all the values over 20 and under 75. But keep the shape and use 2 conditionals to do it. If you need any help with these 2 challenges, please let me know. If you have any questions, please let me know that too. I'll see you in the next lecture about array math. Hey everyone, welcome to the NumPy math lesson. Let's get started. Here in our text editor, I already have the 2 arrays that we'll use for this lecture. We have 2 2x2 arrays, one with 1, 2, 3, 4, and the other one with just 2s and 6s. For this video, it's important to note that both of these arrays have the same shape. They're both 2x2. Whenever one array is a different size than the other, we can talk about a different technique called broadcasting that we'll get to in the next lecture. But for these operations, it's super simple since they're both the same shape. We'll drop down and talk about single array operations. So most of the Python operations that you can do with regular numbers, you can apply to an array as well. We'll say print array A, and then we'll actually use a method called sum. So we'll sum up all the elements within the array. We'll open up a command prompt or a terminal, and the name of this one is array math lesson.py. When we execute, we see that we're getting the return of 10. What this is coming from is the addition of all the elements within the array. So we get 3 here and then 7 here. So altogether, we make 10. If we wanted to sum along an axis, we could use a keyword argument of axis. If we say 1, we're summing up along the rows. And if we say 0, we're summing up along the columns. So let's sum up along the columns. We'll save this and execute again. And now we get the return of 4 and 6. So our column here would be 1 and 3, which makes 4. And then 2 and 4, which makes 6. If we wanted to do the row, we could say 1 and execute our file again. And now we get the row summations. There's a lot more operations that we can apply to a NumPy array, and we won't be able to cover them all. So I'll try to show you the most important ones. Each of the ones that I'm about to show you also have the ability to use this axis keyword. We can take the cumulative sum of an array. So we can say array A and then use the method cumulative sum. Then let's say array A, and we can take the product of every element. So instead of the sum, we can multiply them all. And we can also do a cumulative product. So we'll say array A, cumulative product, and we'll execute our file to see all the results from these 4 lines. So our cumulative sum function is just going element by element through our array and creating a new array of 1 dimension that has all those sums. This new array's length will be equal to the size of your old array. That's because each element creates a new item in this 1-dimensional array. The product function just takes the product of all the elements, and the cumulative product does something similar to the cumulative sum, except using a product. Like I said, you can apply the axis keyword to any of these. Now let's talk about how we can do operations across arrays. So we'll say to array math. So we're taking one array here and doing some operation using a different array. NumPy makes this simple for us, and we can use most of the logic operators that we would in Python on NumPy arrays. So if we wanted to do an addition, we could just say print array A plus array B. And then all the other operators work the same way. So if we wanted to say array A minus array B, we would have no problem. The same with multiplication. So array A times array B. And then we could say array A divided by array B. How these math operators work on NumPy arrays is that we'll go element by element and find the corresponding element across both arrays and do the operation to those 2 elements. Then we'll make a new array of the same size of the arrays before we do the operation. So let's save this file and print to our terminal. We'll go up to the addition one, which is this one here. So we have 3, 4, and 9 and 10. If we go back up, we're taking each element at the same position in both of the arrays and doing that operation. So we have 3 and 4, 9 and 10. We take 1 plus 2, 2 plus 2. So there's our 3 and 4. And then 3 plus 6 is 9, and this is 10. So each of these operations just step through each matrix and do the operation on each of the elements in the same position. Finally, let's talk about how we can take a vector product of these 2 arrays. We'll say print, and then we'll do NumPy dot, and then we'll pass in the 2 arguments that we want to do the dot product on. We'll say array A and array B. We'll save this and execute. And this is our vector product of those 2 arrays. Array math is super simple using NumPy, and we can do a lot of the same operations that we could in Python directly on our NumPy arrays. In the optional project video, we'll look at more math operations that we can use. If you feel comfortable with these, feel free to skip that video. I'll see you in the next lecture. Hey everyone, welcome to the optional practice video for the NumPy math lesson. In this one, we'll look at some more methods that we can use on our NumPy arrays. Let's get started. Here in our text editor, I'll import NumPy as np, and then let's create a few arrays. We'll say array A will have a NumPy array, and it will be the shape 3 by 3. So 1, 2, 3, 4, 5, 6, and then 7 through 9. Then array B will be a NumPy array of the shape 3 by 3. And we'll say this one is 2, 2, 2, 3, 4, 5, and then 6, 7, 8. And then we need surrounding square brackets on that one. Now let's view these 2 arrays. So we'll say print array A, and then print array B. We'll open up a command prompt or a terminal. And we'll type in Python 3 array math project.py. So here's the 2 arrays that we have. We have 2 arrays, both of the shape 3 by 3. Let's get a little more practice on how we can use methods along one axis. We'll say print. We'll specify the array that we want. So array A, let's use the sum method, and then we'll specify an axis. Remember that the 1 axis is for the row and the 0 axis is for the column. So if we say 1 here and save and print this, we're summing along each of the rows. So 6 is summing along here. We get 15 from the sum of these numbers, and then we get 24 for the sum of these numbers. If we change this to 0, now we're saying sum every value along the column. So we're adding 1 to 4, which makes 5, plus 7 is 12. And that's how we get this number here. So now we should know how to use the axis keyword in our method arguments. Now we'll look at a few more methods that we can apply to a single array. We'll say print, and then we'll specify the array. So let's work with array A for this one. And the method that we can use is called peek to peek. They denote this PTP. We'll pass this in with an axis of 1. So we're doing a peek to peek along each row. The peek to peek method takes the maximum value and subtracts the minimum value from what you specify. So since we're saying axis 1, we're doing this along each row. We'll print this, and we get 2, 2, and 2. So the range on each of these rows is only 2. So we take 3 and minus 1 and get 2. The same for 6 and 4, and the same for 9 and 7. If we were to not set an axis here, and just use the method on the entire array, we get back the value of 8, which is just the highest number minus the lowest number. Let's look at a few more methods. We have access to saying array, and then we can use a minimum. We could do array A and do a maximum. And then we also can do array A and do a mean. We could put an axis for each of these if we wanted to, but we don't have to. We'll save and print these. And now the minimum of our entire array is 1, the max is 9, and the mean is 5. Now let's talk a little bit more about multi-array operations. We didn't look at the power function last time, so let's look at that one now. We'll say print numpy.power. The first one will be the base, and the second one will be the power that you want to raise that base to. So we'll say array A and then array B. This is stepping through element-wise and taking the base from here and the exponent from here. We'll print this to our terminal, and we get back an array of the same size. We see that this took 1 and raised it to 2. It took 2 and raised it to the second power and returned 4. And that's how all of these are done element-wise. I also want to note that we can do operations on more than just 2 arrays. Let's create an array C as a NumPy array, and this will be of the same shape as the other 2. So let's say 1, 1, 1, 2, 2, 2, and then 3, 3, 3. We'll put outside brackets. So now we have a third array. If we wanted to, we could add all of these arrays together the same way that we did before. So we could just put plus signs for each one and add them all together. We'll get the result of this, which is this matrix here. We could do the same thing for division. So let's just take this one here. We'll copy it and paste it here and change all these signs to division. And when we do this, remember that the operations are done element by element. So the order of operations here are important. So we'll take the element in the 0, 0 position of array A, divided by the element in the 0, 0 position of array B, and then do the same thing for array C. Not too much to talk about for this video, but hopefully I showed you a few more methods that you can use in your NumPy functions. For your challenge, try to get the product of these 3 arrays and then use the point-to-point method on that new array. Let me know what the result is. I'll see you in the next lecture. Hey everyone, welcome to the last lecture before we get to the capstone projects. In this one, we'll be talking about NumPy broadcasting. Let's get started. Here in our text editor, I already have NumPy imported and 3 arrays created. The first one is a 3x4, so we have 3 rows and 4 columns where it's 1, 2, and 3. The second one is a one-dimensional array of linked 4, and the last one just has 1 value in 3 different rows. The idea behind broadcasting is to allow us to use arrays of different shapes to do numerical operations. We'll drop down and say print array A plus array B. The last lecture, when we did this operation, we had 2 arrays of the same size. Now we have one that is much smaller than the other one. What do you think happens when we try to add this array to this one? We'll go ahead and open up a command prompt or a terminal, and we'll say Python 3 broadcasting lesson.py. When we execute, we see that we get a new array that has these values added to each of these rows. So how does this work? NumPy allows us to use this smaller array to do this operation by broadcasting out this array to the same shape as this array. So that just means that if we were to create another array, so let's say array D, and we'll make it these values here, except instead of having 1 row, we'll go ahead and make 3 rows, the same way as our array A. So we'll say 0 through 3, and then we'll do the same thing again, 0 through 3. And now if we were to add array A plus array D, we should get the same result that we have here. When we execute, we see that we do. So broadcasting means that we don't have to worry about these being the same shape if we want to do this operation on the entire array. So broadcasting saves us time by not having to type this out. Instead, we can use a compatible shaped array. There's a few different ways that we can make compatible arrays, but for this course, we'll focus on two. The smaller array, to be compatible, needs to have one dimension of 1, and then the other dimension needs to match that of the larger array. So in this example, this array has a dimension of 1 when it comes to the rows because it has one row, and the columns match the number of columns on this array. We could flip this in how we have the array C example. So in array C, we have 3 rows and only 1 column. That means this array is also compatible with this array. So the operation of array A plus array C should be a valid operation, and we should add 1 to everything in the first row. We should add 2 to everything in the second, and then 3 to everything in the third. We'll print this now, and that's the result that we get. Broadcasting, of course, can get more complicated than this. However, if you just take away from this lecture that if you create an array that has a dimension of 1 and then the other dimension matches that of a larger dimension, you can do that operation along that entire axis in the larger array. I know that's pretty wordy, and if you want to see more projects using broadcasting, we'll do that in the optional project video coming up. If you feel comfortable with this concept already, then feel free to skip that. I'll see you in the next lecture. Hey everyone, welcome to the optional project video for NumPy array broadcasting. Let's get started. Here in our text editor, I already have NumPy imported, and I have a sample array. So let's see how we can use broadcasting to do operations on this array. Like I said, there's a few other ways to make an array compatible, meaning that we can use it to do operations on this larger array, but we'll focus on two main ones for this course. The first way is to have one row and then match the number of columns of the larger array. And the second way is to match the number of rows and only have one column. So for our first example, let's have one row and then match the number of columns in our larger array. We'll create array B, and this will be equal to a NumPy array, and we need this to be a one-dimensional array of length 3. So let's say we wanted to add 3 to every first element, add 2 to every second element, and then add 1 to every third element. Now that we have this array, we can drop down and say print array A plus array B. We'll save this and open up a command prompt or a terminal, and then we'll type in Python 3 broadcasting project.py. We'll execute, and when we execute, we see that we've successfully added 3, 2, 1 to each row of this larger NumPy array. Now let's see how we can do it the other way. Let's see how we can match the number of rows but keep only one column. We'll drop down and say array C, and this one will be a NumPy array of 3 rows. So we'll say 3, 2 for the second one, and then 1. Now we can do the same operation and do an addition. So we'll say print array A plus array C. We'll execute our file. Looking at this from a column perspective, we're just adding 3 to everything in the first value of each column, which is everything in this row. So we're doing 1 plus 3, 2 plus 3, and 3 plus 3 to get 4, 5, and 6. And then we're doing the same thing with 2 and 1 with this row and this row. So there's a few key points to remember. Whenever we have a compatible array, we can use broadcasting to do some type of function onto a larger array. Compatible arrays will have the same number of dimensions on one side, so the rows or the columns, and then it will have a 1 on the other side. Your project challenge for this video is to see if you can create a 5x5 array of all 1 values. Once you get that array, make a smaller one that you can broadcast a multiplication of 1, 2, 3, 4, 5 onto that array. So your finished product should be an array of 5x5 where every row has the values 1 through 5. Let me know if you need any help in figuring this one out. Remember that there's a default array method that we learned earlier on that may help you creating the initial array. If you have any questions, please let me know that as well. What's up guys? You made it all the way through the course. Congratulations. Now you should know all the basics of NumPy. You can start applying NumPy to any Python script. It speeds up operations immensely, and I hope you now know how to use it. NumPy is a fundamental package of Python. Whether you're a developer or a data scientist or just playing around with Python, you'll find use cases for NumPy everywhere. In fact, NumPy has so many use cases that other libraries will often take NumPy and incorporate it into their own library. A few examples would be TensorFlow and Pandas. I work with these two libraries a lot on my YouTube channel, so if you would like to see more practical use cases of NumPy, feel free to subscribe to me there. And lastly, I want to say thank you one last time. I know there's a lot of courses on Udemy, and I want to thank you for learning with me. I hope this course was beneficial to you. If you would like to get more courses from me, I have a mailing list on my website that I give special offers to every student. So if you want to get more course content from me in the future, feel free to sign up there. I'll put the link to that in the description as well. So that's it for me. I hope this course was able to teach you something about Python or NumPy. If you have any questions or comments, feel free to reach out to me and I'll get back to you as soon as I can. If you have any feedback on the course, please let me know that too. I'm always looking to improve to help future students. Until next time. Hello everyone. In this video we'll talk about how we can download Python and start using it. You might already have Python installed in your system if you're using a Mac like I am. So if you open up a terminal, you might be able to type in Python and see a Python shell. That's because a lot of MacBooks already come pre-installed with Python on them. We see that this version though is Python 2.7, and this isn't what we want to use. Python has two different versions. Python 2 is the legacy version of Python, and Python 3 is the new version. We want to be sure to use the new version because this is what will be updated in the future. So let's go ahead and close out of this, and then we'll open up a window and pull up the page python.org/downloads. And we see that the newest version of Python right now is 3.7.3. Let's go ahead and download this, and we see it downloading in the bottom left corner. Whenever it finishes, we'll open it up. We'll go through the installer.
A few moments later.
And it looks like we've successfully installed Python 3.7. We'll close this and move it to the trash. Now that we have Python 3 installed, we should be able to open up a terminal again. And this time, instead of typing Python, we'll type in Python 3. So this is denoting the version Python 3 instead of the default factory Python version 2. We'll hit enter. And now when we enter this into the terminal, we see that we're running Python 3.7, and that means we're good to proceed. We'll go ahead and close out of this, and close out of this one as well. Now the next step that I want to do is to get a text editor. Let's go back over to our window, and we'll type in atom.io, and this is the text editor that I'll be using in this course. So Atom is just an open source text editor, so that means that the community can build packages and themes for it to improve our experience using it. We'll go ahead and click through and download this. I already have it, so I'll just open up my Atom text editor. This is what the default view of Atom looks like. We'll go ahead and click Atom, and then we'll drop down to Preferences. And there's a few packages that I would recommend to install for this course. The first one is autocomplete-python, which is just an auto-completion tool that we can use when we're coding in Python. And then platform.io-IDE-terminal. What this does is it gives us this little terminal down here in the bottom left corner that we can open whenever we want. This by far is one of the most helpful packages for me whenever I'm coding. So I would encourage you to get those two. And then the themes that I'm running, if you want to follow along completely with how mine looks, is OneDark in the user interface theme, and then for the syntax theme I use OneDark as well. You don't have to choose these themes, and there's a lot of creative themes from the community as well that you can use. But these themes are very nice for me because they show up brightly whenever I'm recording videos. I'll go ahead and exit out of the settings and jump back up and create a new file. I'll increase my font size. First thing we should do is hit Command S, and we'll save this as a Python script. So every Python script ends with the extension py. We'll say example.py and click Save. I already have one, so I'll replace it. Now Atom automatically gives us a directory here as well. So since I'm working in my desktop, everything on my desktop appears here. This is very useful for navigation whenever we have large projects. But for now, since we just have one script, I'll go ahead and close it. Let's go ahead and create our first Python script. So the very basic one that everyone does and that you have to do as well is using the print function. A function is just denoted by the parentheses after a word. So here we have the function print, and we know it's a function because of the parentheses. This function takes in whatever you pass here of the same data type and prints it to the terminal. So let's say hello world. We'll save our file. We'll go ahead and go down to that terminal, and then we'll type in Python 3 and then the name of the file. So ours was example.py. Hit return, and we see that the return to the terminal is the hello world that we passed to the print function here. And congratulations, you just wrote your first Python script. We'll keep on building on this, but for this video, it's important that we have Python downloaded and we have a text editor ready to go. I'll see you in the next one. Hey guys, welcome back. In this video, we'll talk syntax and commenting. Let's get started. So back in our text editor here, we have the print hello world statement from the last video. Now let's talk about how we can make a comment in our Python script. A comment in a Python script is just a line of code that isn't executed. So these are often notes for developers or programmers. So we can leave notes in our Python scripts throughout to let us know what we were thinking at that time. If we wanted to put a comment above our first line of code, we could drop that line of code down and then use a number sign. This number sign just denotes a comment, and this line is not read whenever we execute the Python script. What we'll do is we'll put the number sign and then try to always put one space after your comment. Then we'll pass in the comment that we want here. So this is our first Python script. And that's how we would make a comment in Python. Block comments in Python are done the same way. So if we wanted to do a block comment, we could drop down, put another pound sign, and then put in another line of text. This is a comment. The more comments you put in your script, the better it usually is, because this means that someone else can pick up your Python script and understand what you were thinking whenever you were writing it. Since Python emphasizes the ability to be able to quickly look at a Python script and understand what's going on, comments are always a good thing. Now let's talk about the syntax of Python. Python is one of the few programming languages that uses white space. Let's say that we have a block of code that looks like this. We have a variable x is equal to 1, and then we want to make a simple function. So if x is greater than 0, we'll put a colon here. Now watch what happens in the text editor whenever I press enter. It automatically spaces over 4 spaces. So whenever we have an indented block of code, we know that the control flow happens here. We know that anything that happens here belongs to this if statement. We'll use our function print, and then we'll say x is greater than 0. We'll save our file. We'll drop back down to our terminal. We'll execute the script again by pressing up, and then we'll hit return. And now we see we get the return x is greater than 0. This is because x is equal to 1, so therefore it's greater than 0, so we get this command. We see that if we were to change this to a different logic statement, so x is less than 0, hit save and execute again, we see that we don't get the return in this case. But we can drop down and put an else statement. So else here we see is lined up with the if statement. That just means that this new block of code doesn't belong to this if statement. It's actually its own statement, but whenever we drop down to the next line, it should be indented, which it is. We see that anything we put here now belongs to the else statement. So this is a new block of code. We'll use the print function again. X is less than 0. Now when we execute, we see that we get that return. Indentations can be thought of as just blocks of code. Here we have 2 blocks. Each control statement is at its own indentation level. We see that the if is lined up with the else. Each block of code following the logic statement is at its own indentation level. Each indentation level is just 4 spaces from the last one. Here we may be tempted to hit tab whenever we're indenting, but tabs may not be consistent across operating systems. So it's encouraged that we use 4 spaces to do this indentation. It's okay if you don't quite understand the logic of the if and else right now. All that's important for this video is that we understand how we can make a comment and also how we can indent blocks of code. In the next video, we'll dive into variables and data types. I'll see you then. Hey everyone, welcome to the next video. In this video, we'll talk about variables and data types. Let's get started. Back in our Python script where we left off, close our terminal and go ahead and delete everything in our Python script. So let's go ahead and drop down and create a variable. We already did this once where we set x equal to 1, right? But variables in Python need to be descriptive. Right now, since we're just starting out, x as a variable is fine. But in the future, a variable name should be something that actually makes sense. This could be something like age, maybe name, or something along those lines. Right now, let's go ahead and use the age variable. The first thing about variables is that we should type them with lower cases. Here, I put age with a lowercase instead of age with an uppercase. With the capital A, this may confuse people that have been using Python for a while because we tend to leave the capitalization to the class objects. Let's go ahead and change this to age with a lowercase, and this is now a variable. The cool thing about Python is that we don't actually have to explicitly state what type of variable we have. All we have to do is type in what we want this variable to equal. You already saw how we set the last variable x equal to 1. We can do the same thing with age here. So let's save our file, and then we'll drop down and use the print function again. And now let's introduce a new function. Let's use the type function, and then we'll pass in the variable that we want to this function. We'll say age here. What the type function does is it returns the data type of the variable that we passed to it. Let's open up our terminal again and type in python3 example.py. Make sure you have your file saved, and then we'll hit execute. And now we see that we returned a class of an integer. Python has a lot of different data types, but let's just talk about 3 main ones right now. Integers are just positive or negative whole number values. Here, since 1 doesn't have a decimal place, it's an integer. If we were to change this to 1.5 and execute our script again, our class now changes to a float. A float is just any number that includes a decimal point. Lastly, let's talk about how we can make a string. Instead of typing in a number, let's put in something called a delimiter, which can either be a double quotation mark or a single quotation mark, and then we'll pass in text. Drop down in executing, and we see that we now have a string class. This is something that a lot of beginners really enjoy about Python. We didn't need to denote anything other than what we wanted the value to be for a variable. In other programming languages, you would typically have to state what type this value is whenever you assign it to this variable. In Python, it does all the heavy lifting for us and automatically places a type to this value. This can get us in trouble sometimes though, because what if we want a float number and Python thinks it's an integer value? Let's drop down and say number. We'll set this equal to the number 1, but let's say that we wanted this to be returned as a float number instead of an integer value. We could just use something called casting in Python. What we'll do is we'll say float and then use it as a function and pass in what we want to be a float number. Now, instead of this returning as an integer, it should return as a float type. We'll drop down and say print type and then number. When we execute, we see that we're given a float, even though the default behavior in Python would have been an integer. We have access to do this with string, int, and also float. Lastly, let's talk about how we should create multi-word variables in Python. Let's drop down and say number, and then for the second word, we should put in an underscore to separate the two words. So number, and then let's say and age. We'll set this variable equal to a tuple, which we'll talk about later on in the course. And we'll say number and age. Now we can drop down and print number and age. When we do this, we get the return of both of these in a tuple to our terminal. Don't worry if you don't quite understand this tuple yet. We'll talk about that later on. What we should take away from this lesson is that variables can be uppercase, but we should keep them lowercase and separate multi-word variables using an underscore. We also have access to a lot of different data types, and we're able to explicitly state those data types using casting only if we want to. Lastly, Python makes it very easy for us to create variables because it automatically assigns a type depending on the value of the variable. If you got all this, you're good to move on to the next lesson. We'll talk about composite data types. I'll see you then. Hey everyone, welcome back. Let's talk about composite data types in this lecture. The first thing we need to talk about is an immutable and a mutable data type. Simply put, a mutable data type is something that we can change once we create it as a variable. An immutable data type is one that we cannot change once we create the variable using that data type. We'll talk about this more whenever we get to the specific data types, but we just need to remember mutable means changeable and immutable means that we cannot change it. But for now, let's talk about the composite data types that we have available to us. We can create a list, a tuple, a dictionary, a frozen set, and also a set. Let's go through the structure on each of these. We'll start out with a list, so we'll create a variable and say our list. We'll set this equal, and now a list is denoted using square brackets. So we'll use 2 square brackets, and everything that we put in between these square brackets belongs to the list. So let's say that we want to pass in A, and then put a comma, B, and then C. What each of these composite data types do is allow us to put multiple values to one variable. Each one of these just allow us to do it in a different way. For a list, we're able to pass in multiple values, and we're able to keep the ordering of the values in the list. So the first value will always be A, and the second value will always be B. A list is also able to store multiple data types. So if we were to put another comma and put 1.5, drop down and say print our list, save our file again, and then we'll execute this script. So Python 3, and then example.py. And we see that our list is returned in square brackets of multiple different data types. We have strings here because we know the delimiter means a string, and we also have a float number because we have a decimal place here. A tuple is almost the same thing as a list, except that it's immutable. We'll talk about that later on in our list video, but for right now, we'll just look at how we create them. So we'll say our tuple equals, and then instead of square brackets here, we'll use parentheses. Now we can do the same thing as we did before. So we'll say A, B, and then also C. We'll drop down and print our tuple, execute it to the terminal. We see that we get the same thing, except it has parentheses instead of the square brackets. Now let's talk about a dictionary. So we'll say our dictionary, and then we'll set this equal to curly brackets this time. And instead of just having one single value in a dictionary is composed of a value and a key. So these pairs are what make up a dictionary. We denote these by using the key first, a colon, and then the value. So let's say our key is key 1 as a string, and then our value will be value 1. Now a dictionary is powerful because we can pass in multiple pairs into the dictionary for storage. So we can say key 2, colon, and value 2. We'll print this out, so our dictionary, and we'll see what the return looks like. The dictionary is returned the same way that we type it. Dictionaries are useful whenever we have multiple properties about something. So let's say we change the key to name, and then we'll use my name, so we'll pass in Derek, and then we can change the second key to another property about me. So let's say key 2 will be equal to height, and then we can say 6 foot. Now let's go ahead and talk about a set. So we'll do this one first. We'll drop down and say our set. And then sets are created using curly brackets as well. But instead of key value pairs, it's just single elements. So we'll say 1, the second one 2, and then the third one 3. We'll go down and print our set. And when we print, we see that we have a set here. But what's the difference in using a set and using a list? Well, a set is unordered. That means it doesn't keep the order here. So we see that 2 is in the first position instead of in the second position, like how we put it here. And then it also has to be unique. If we were to include a repeat, so let's put 2 again and save this, we should only be returned one string 2 in our set. Here we see that's exactly what we get. These are useful if we're doing unions or intersections or something of that nature. Now for our last one, let's say our frozen set. And a frozen set is just like a set in the same way that a tuple is just like a list. A frozen set is just the immutable version of a set. We can use frozen set and then pass in the set value that we have. We'll drop down and say print our frozen set, and it should look very similar to our set. We see that it does, except that it has the parentheses around it, denoting it as a frozen set. We'll look at what we can do with mutable and immutable objects in the upcoming lectures. For now, we just need to know that there's a variety of different composite data types that we can use in our Python scripts. I'll see you in the next video. Hey everyone, let's talk about numbers in this lecture. Let's jump right in. Let's create a new file since I don't want to get rid of this one. We'll save this one as example2.py. Close the terminal. And now let's go ahead and import our first package called math. To do this in Python, all we need to type in is import and then the package that we want. This one is just called math. And the math package just gives us access to a lot of different operations that we can do on our numbers. We'll drop down, and we already know that we can create integer values, and we can also create float values. Python also gives us access to use complex numbers. We'll say z is equal to the real part of the number, 2, and then plus 3j. The j here just denotes this number as a complex number. If we were to drop down and say print type of the variable z, open up a terminal and execute our Python script, so python3 example2.py, we see that the class is complex. Let's go ahead and close this. In Python, it's very easy to do math operations because they're already built in. We can drop down and say result equals, and then x plus y, and print result to the terminal. When we execute this, we're given the addition of y plus x. You see that Python doesn't care about these two data types being different. If we wanted to do multiplication, we could use an asterisk. If we wanted subtraction, we could use a hyphen. And if we wanted division, we could use a slash. These are all built into Python already, so we don't have to do anything special to use these. However, let's talk about how we can use the math function that we did need to import. Whenever we imported this into our Python script, it gave us access to a lot of new functions that we can use. We can look at the documentation on the Python website, but all of these represent some type of new function that we can use in our Python script. Well, let's go ahead and use one of these. Let's say we want the ceiling. The smallest integer greater than or equal to x. We'll go over, and to use that, we saw that we need to type math dot ceil and then pass in the value. So let's drop down and say print math dot ceil, and then we'll pass in the value. So let's pass in y. We'll save the file and execute. And we see that the ceiling function did exactly what we thought it would and returned the lowest integer higher than our number. In this case, that was 2. It's okay if you don't quite understand this part just yet. We'll have a whole lecture on how we can start using packages that other people have built and using their functions inside of them. So don't worry just yet if you don't understand this. But what we should understand from this video is that we have 3 different data types and numbers, where we have integers, floats, and complex numbers, and we also have the ability to do simple math operations already built into Python, such as addition and subtraction. And that's pretty much it for this video. I'll see you in the next one. Hey everyone, in this video we'll cover Python lists. Let's get started. In our text editor, let's go ahead and open up a new file. And I'll go ahead and close these out, that way we don't have them. And now the first thing we need to do is let's create a list. So we'll say our list, and then remember we denote these using square brackets, and then we pass in objects into these square brackets. So let's say A, and then we'll say B, and then we'll say C as well. I'll save our file, that way we get the highlights. So let's say list.py. And remember that a list can be a multi-type container. So we don't have to put in just string values, we can put in integers, float numbers, and any other data type that we want as well. We'll drop down and say print our list. Saving this and executing it. We'll say list.py, and we see that we returned a list in the terminal. So we know how to create a list, and we can do it just like this. But if you remember, a list is also a mutable object, and that just means that we're able to change it once we create the variable here. So if we wanted to change the rList variable, we could drop down and say rList, and then if we wanted to add something in, we could append it. So append parentheses, and then we can append whatever we want here. So let's say we wanted to append the letter D. If we were to print our list again, we'll see that we have a new list in our terminal, which we see that we do. We now have the string D and our list value. This is possible just because the list is mutable. If we tried to do this with a tuple, we wouldn't have the same result. If you remember as well, a list also keeps the order of the elements inside of it. No matter how many times we were to print our list, this will be the order of these elements. Since this data type keeps the ordering, that means that we're able to index values out of it. Indexing is just using the index position of an item inside of a data type to pull a specific element out of it. Let's try to only pull out the element A from our list. We could drop down and say print our list, and now anytime that we index values out of a data type, we'll use a square bracket. So we have our list, which is the variable here, and then we're using square brackets to pull out certain values within our variable. So if we're only trying to pull out A, Python starts in the 0 index position. And what that means is that A is in the 0 position. So A would be 0, B would be 1, C would be 2, and so forth. To pull out A, we use a 0. So we'll put a 0 here. And now when we execute, we should just be returned A, which we are. Like I said, a list keeps the order, so that's what makes this possible. It also makes it possible for us to insert elements at a certain position within our list. We'll drop down and say our list, and then we'll insert parentheses, and now we specify the index position of the place that we want to put the element. So let's put it at the very beginning, and now we'll put in the element. We'll put in first element as a string. Now when we print our list, we should have a first element string at the very beginning of the list, which we do. We're also able to remove that element from the list if we want to. We can drop down and say our list.remove, and then specify the element that we want to remove. So let's specify first element, and now when we print our list, we shouldn't have that element in our list anymore, which we don't. We also could have done this using the pop method. If we wanted to remove a certain index position from our list, we could have used pop. We'll put parentheses, and then we'll specify the index position that we want to remove. So let's remove the last one, D, which is in the 0, 1, 2, 3, 4, 5th index position. We'll put in a 5 here, and now print our list again. When we execute, we see we no longer have the string of D in the last position of our list. Lastly, we can nest lists inside of each other. So let's say nested list is equal to another list, and then we'll pass in a second square bracket, which will be just another list inside of the first list. So this will be the first list. So let's say 1, 2, 3, and then the second list will be 3, 4, 5. All we're saying is that there's one big list with a smaller list inside of it. We'll print nested list to see what it looks like. We see that it looks exactly like how we typed it in the terminal as well. And that's it for this video. It's important that we remember that a list is a mutable object and that we're also able to keep the order of elements inside of our list. I'll see you in the next video. Hey everyone, let's talk about how we can use strings in our Python scripts. Let's get started. Over in our Python script, I'm in a file called strings.py. We've already been using string variables quite a bit, but there's a little bit more that we need to talk about. Let's create a new variable called string A, and then if you remember, we use a delimiter to specify a string. A delimiter is either a double quote or a single quote. We'll use double quotes here. And now let's set this equal to a name. So we'll just use mine, Derek. It's very easy to create strings in Python. However, there's a lot happening behind the scenes. This string in Python is actually an array. So if we were to drop down and say print, and then we'll use a new function called len, which just calculates the length of the array. We'll say length, parentheses, and then string A. Now when we execute this, we'll see what I'm talking about. We get the return of 7. That's because each letter in my name is actually a single element, and they all combine together to make this string, which has an array length of 7. So the same way that we were able to index list values, we can actually do that here too. If we drop down and say print string A, and then the same way that we indexed before using square brackets, we can do the same here. So let's pull out the first letter of my name. So we'll use a 0. Now when we execute, we should just be returned a D, which we are. We also have a few different functions that we can apply to strings. I'll just show a few of these. We can say print string A, and then we can use the function upper to make my name entirely uppercase. We see this in the terminal because every letter in the array of this string is now capitalized. We also have access to the reverse function of lower. We're also able to split strings in Python. So let's say string B is equal to my name, so Derek, Matt, and then let's say Jessica. And now if we wanted to return each name individually, we could drop down and say print string B, and then use split as a function, and then we'll pass in the character that we want to split on. So let's split on the comma value. We'll put parentheses and then a comma, save, and then execute our file. Now we see that we have 3 values of strings in a list. We have Derek, Matt, and Jessica. So that's pretty much it. We know how to create a string. We know that a string is actually made up of an array of elements instead of just one element. We know that we can calculate the length and how to index a string. We now know that we have functions that we can apply to the strings, and we're able to split strings as well. If you have any questions about this, please let me know. I'll see you in the next video. Hey everyone, let's get started talking about tuples. Over in our text editor, let's go ahead and create a tuple. We'll say tuple A is equal to parentheses, cat, dog, and mouse. Remember that we specified tuple using a parentheses and that they're very similar to a list object. The only difference is a tuple is immutable. So this can be useful if you want to create a list but don't want people to be able to change it. We can create a tuple instead which is immutable and doesn't allow for that change. If we were to try to do that here, say tuple A dot append how we did in our list and pass in some type of value, so value, and save this and execute it, we should get an error in our terminal. So tuples.py. We see that tuple object has no attribute append. That's because it's an immutable object and we can't change it. So let's go ahead and get rid of this line of code. Or if you remember, a tuple does keep the order. Therefore, we are able to pull out values from our tuple using indexing. We can print tuple A, square brackets, and then let's pull out the word dog, which is in the first index position. We'll put in a 1, and now when we execute, we should be returned just dog. Tuples are one of the more uncommon data types that we have in Python. However, we still need to know how to use them. We can sometimes find ourselves using tuples whenever we're working in a coordinate plane. If we have a bunch of x and y values, tuples are probably the way to go. We use tuples from time to time, but really not that often. I'll see you in the next video where we'll talk about sets. Hey everyone, let's start talking about sets. Sets are just unique element containers. We already saw this briefly, but let's create another one. So let's say set A is equal to curly brackets, and then we'll create a set. Let's say 1, 2, and then 3. We also know that sets are mutable. We can see this by saying set A, and then we can add an element to a set. We'll put in parentheses the string 4 to our set A. We'll drop down and say print set A, and see what the return is to our terminal. Python 3, and then I accidentally typed over a previous script of tuples.py, but we see that a set is an unordered because we have 1, 4, 2, 3 in our return when we put in 1, 2, 3, and 4. So it's an unordered. That means we cannot use indexing on a set, and it is mutable as we were able to add a new element to our previous set. If we wanted to add multiple items to our set, we could drop down and say set A and use the function update. Now we'll put parentheses and we'll put in square brackets to create a list of items. and then we'll say 5, 6, and then 7. We'll print set A and execute it through our terminal. And we see that we can add one element using add, and we can add multiple elements using the update function. If we want to get rid of elements from our set, we can use the functions discard and remove. Remove just returns an error if the item is not in the set. Discard will just return none. Both of these are used the same way, so set A, remove, and then we can put in any element that we want. So let's remove the string 6. And now we should no longer have the string 6 in our output, which we do not. Now if we were to try to remove the same element again, and it's no longer in the set, we'll see the error that would get returned. So set A, remove, and then we'll remove the same element, 6. We'll just try to do this without printing, and then we'll say Python 3 tuples NumPy. We see that we get the error, key error, 6 on remove 6. If we were to change the second remove function to the discard function, we should no longer get that error. When we execute, we see that it just returns a none, and we no longer get an error. Lastly, we're able to remove an element from a set using the pop function. We'll drop down and say set a.pop. And now this function is kind of dangerous because it's going to remove the last item in the set. However, we know that a set is unordered, so there's no way of knowing which item will be removed using the pop function. And since I'm such a fan of danger, we're just going to do it anyways. So print set A, and we'll see what happens. We'll execute. And from the terminal, we'll see that the string 1 has been removed. Remember that a set only contains unique values, so if we have multiple elements in a set that are the same value, the set will treat it like there's only one element of that value. A frozen set is very similar to a set, and we just use the frozen set parentheses, and then we can pass in set A to it. We'll create a variable, so f set A. And what our frozen set does is changes our set from a mutable to an immutable object. It means that we can no longer do these functions of remove, update, add to our frozen set. So you would use this whenever you wanted a set but didn't want any of the values to change. And that's pretty much it for this one. What we need to remember is that a set contains unique, unordered elements, and a frozen set is the immutable version of a set. I'll see you in the next video. Hey everyone, let's keep on going and start talking about dictionaries. Let's start off by creating a variable. We'll say our dictionary, and we'll set this equal to curly brackets, how we did before. And then remember that a dictionary is full of key value pairs. So the first item in the key value pair is the key. We'll say key 1, how we did before, and then value 1. We'll put a comma, and then we'll actually hit enter here and do our first multi-line variable. So then we'll say key 2, colon, value 2. We'll say print our dictionary, and then save our file. We'll type in Python 3, and then the name of this file is dictionaries.py. We see that we have a dictionary made up of two key value pairs. Key 1 is related to value 1, and key 2 is related to value 2. Now remember that our keys can be some type of property. So let's say how we did before, name, and then the value of name for me would be Derek. We could say height, and then we can pass in 6 foot, so 6 foot. And now we can also keep on going and create as many key value pairs that we want. So let's say another one, and we'll say location, and we'll give me a location of lost. Dictionaries are very powerful to us, and we'll use them a lot. The reason why is we can use these keys to pull out information from our dictionary. Put square brackets, and then we can put name. This should return to us in the terminal my name, which it does. This makes it very easy for us to pull out properties values using a dictionary. We're also able to change these values because a dictionary is mutable. We can do the same thing, so we'll actually just take this line of code here, we'll copy it, paste it here, and then let's change the name. So instead of Derek, let's say that my name is now Michael. Now we'll drop down and say print our dictionary. We're readily able to change the values in our dictionaries using this method. This is a very nice feature that you may use a lot. So we know that we can change values, but let's say that we wanted to add a new value to our dictionary. We could do the same thing that we did before, say our dictionary, and try to index a value. But if we change this value to something that's not already in the dictionary, we create it in our dictionary. So let's say eye color is equal to blue. We'll print our dictionary. And since the key eye color is not already in our dictionary, it should create this key in our dictionary. We'll drop down and execute. And now we see that our dictionary has name, height, location, and also eye color. If we wanted to get rid of this, we could say our dictionary and then use the pop function that we learned in the sets lecture and pass in eye color. It is cap sensitive, so that's why you saw me backspace the capital E and replace it with the lowercase e. Print our dictionary. We should remove the eye color key that we just added in. We see that we have. Like I said, dictionaries are very powerful and they're a very good tool for us. The takeaways from this video are that dictionaries are made up of key value pairs and that we can pull out values using the keys. I'll see you in the next video. Hello everyone, let's talk about if loops. Here in our text editor, let's go ahead and create 3 variables. We'll say x is equal to 1, y is equal to 2, and z is equal to 3. Now, to start an if loop, we need to use the keyword if. We'll say if, and then we need to pass in some type of logical statement. This can be anything like greater than, less than, not equal to. For now, let's say x is less than y, and then to end an if statement, we need to use a colon. Now we'll drop down and notice how we're indented over. That's because this block of code follows this logical statement line. So everything in this block will only be executed if this is true. We'll say print x is less than y. When we open up a terminal, we'll type in Python 3 and then the name of my file is if.py, and we see that this statement is true because we get this block of code returned to us. This is because x is equal to 1 and y is equal to 2, and 1 is less than 2. If we were to change this to greater than and execute our file again, we should get no return in the terminal, which is exactly what happens. In this situation, we need to create an else statement. If we go down and say else, then this means this line of code will only be executed if this line returns false. We'll drop down and see that it's indented as well because it follows this else statement. And we'll say print, and then we'll pass in victory. We'll execute, and now we should see victory in the terminal because x is greater than y returns false. We already saw that we don't have to include the else statement, but sometimes we want an action to happen whenever this statement is false. We also have access to a few different operators. Those operators are and or. We'll look at how we can use the and function now. Let's go ahead and change this back to less than. We'll use the keyword and y is less than z. We'll print to the terminal and we'll say something simple like yes. So the and keyword just means that both of these logical statements have to be true to get this action to happen. We'll go ahead and delete this else statement. And now when we execute, x is less than y and y is also less than z. So we should be returning this action to our terminal, which we are. Now, if we were to change this to y is greater than z and execute again, we should see no return in the terminal. That's because, like we said, one of these statements is not true, therefore the whole line returns false. If we were to change this to or, however, and execute it again, we'll get the return because in this scenario, only one of these has to be true to return the whole line as true. If loops are very straightforward and they're very powerful to us. All we need to remember is that we start an if loop with the keyword if, we have some type of logic statement, we end the line with a colon, and then we have an action underneath. We also have access to an else statement if we want something to happen if this line returns false. We'll get plenty of practice with if loops, so don't worry if you don't have it down just yet. I'll see you in the next video. Hey everyone, let's continue on and start talking about while loops. A while loop just executes a code while some condition is true. We need to create that condition, and the most common way that people do is they say I is equal to 1. To start our while loop, we'll drop down and use the keyword while, and now we need to say some logical condition. We already have I is equal to 1, so what we'll do is we'll say I is less than 10, and then we'll end our while loop statement with a colon. Now we need to create some action here. It's important that we don't create an infinite while loop, so we need to somehow make this variable I greater than 10 to end our while loop. So for each iteration through this while loop, let's say I is equal to I plus 1. Now we can do some type of action. So let's say print I. So looking at this, while this statement returns true, we want this action to be repeated over and over. We'll save our file, and now we'll open up a terminal and say Python 3 forloops.py is the name of my file. Hit return, and we see that we iterate through that action until I is greater than 10. Because we print I each time, and we see that we just iterate 2, 3, 4, 5, 6, and so on. While loops are very straightforward if you understand the syntax of Python. We start our while loop with the keyword while, we have some type of logical operator, and then we have the action of this line indented underneath. We can also nest while loops the same way that we nested if loops. We can drop down and actually use an if. So if I is equal to, let's say 6, let's say that we want to break. And that just means that we want to stop any of the looping action. We'll do this, we'll save and execute. And now instead of while being less than 10, we can say if I is equal to 6, we break the while loop, which is exactly what we've done here. While loops are just one more tool that we can use in our looping process. If you have any questions, please let me know. In the next video, we'll start talking about how we can use for loops in our Python scripts. I'll see you then. Let's talk about the last of our iteration techniques and talk about for looping. Here in our text editor, let's go ahead and create a string. We'll set a variable of name equal to my name again, so Derek. Now to create a for loop, we start with the keyword for. And now what we need to specify is what we want each individual element inside the larger grouping to be called. So let's say for element in name. If you remember, a string is not just one string, but actually an array of string values. So here we have one string value here, one string value here, and so forth. Here we have 7 string values. When we say for element in name, we're saying each element, so each string value, each letter in the variable name. We can print each element, which is just what we're calling each letter in this name. So print element. We'll save and execute Python 3, and then this one is for loops.py. And now we see that for each letter in my name, we print to the terminal. We can use for loops in a lot of different ways. So let's say that we have a list A, and this is composed of a grouping of names. So Derek, Michael, and then Jennifer. We'll drop down and we'll say for name in list A, colon, we'll print name. Now, since the elements are actually list items, instead of the individual string characters, we'll return each name through the iteration. So we'll go down and print these. Since the values making up a list are actually the groupings of the strings, rather than the individual letters making up the strings, we'll return each complete string through the iteration. If we were to put in numbers into our list, we could expect the same thing. So we'll save, and now when we iterate, we'll return all the string groupings and the numbers. For loops are a great way to pull out values, but they're also a great way to do operations. So let's create a new list. We'll say list B, and then this will be a list of numbers, 1, 2, 3, 4, 5. For number in list B, we'll say print number plus 5. This is saying that we want to add 5 to every number in the list B. We'll execute, and we see that our list of 1 through 5 now becomes a list of 6 through 10. Lastly, a for loop doesn't necessarily have to use this keyword here. Instead, we could just say print 5. This will return 5 to us for each element in the list. So since we have 5 elements in the list, we'll be returned the number 5 to our terminal 5 times. We can execute, and we see that we have the number 5 times in the terminal. For loops are one of the most common iteration practices that we'll use, and we'll get plenty of practice in the upcoming videos. If you have any questions, please let me know. I'll see you in the next video. Hey everyone, welcome to another video. So you've made it through all the tough parts of Python. You understand the basic building blocks. So let's start thinking about how we can combine those building blocks together and create functions. Let's get started. Here in our text editor, we can declare a function by using def. Now we use the name of the function that we want. So let's say that we're creating a function that adds 2.6 to any value that we pass it. We'll say add 2.6 and then put parentheses after it. Now we need to pass in the parameters that we want this function to have. Since we just want to take in a number, that means we can just assign any variable that we want here. Let's say x. Now we'll end the function with a colon. Underneath it, we need to make the action of the function. So we want to add 2.6 to any number passed to our function. We'll say result. So we're creating a new variable is equal to x plus 2.6. Now we want to print result. So this seems like a very basic example, but we can do a lot with functions here. There's a few important things that we need to talk about. A function always starts lowercase and it follows the same naming convention as a variable. So it starts lowercase and each of the words are separated by an underscore. And ideally, a function should only do one thing. So here we're only adding 2.6, which is fine. But if you need to do several different operations, you should create different functions for each of them. We'll drop down now and we have this function created. So now we can just create a variable. We'll say amount is equal to our function add 2.6, and then we'll pass in a parameter which will be treated as x. So let's pass in an integer value of 7. We'll save our file. We'll drop down and type Python 3, and then the name of the file is functions.py. We can see that we return 9.6. This may not seem like a lot, but creating a function can actually be very useful to us. Here, we just use one line of code when before we would need two. We would need to add 2.6 and then print the result. Instead, we created a function to do both of those for us. The more complex your operation is, the more useful it is to create a function. So instead of just adding 2.6, let's say we needed to add 2.6 and then divide it by 5.5. And now we start to see just how powerful a Python function is. We see that we can start creating Python functions that automate processes that we do repeatedly. In the next video, we'll talk about how we can take this even farther and start creating class objects. I'll see you then. Hello everyone. Let's dive into the true object-oriented programming nature of Python. We'll look at how we can create our first class. Let's get started. So this video might get pretty technical pretty quick, but I'll try to keep it very simple here and then put all the technical stuff in a different video later on. To create a class, it's very similar to a function. We'll call in class instead of def. And for a class, it's common to capitalize the first letter. So let's say that our class is going to be report. We'll put a colon and then we'll drop down. Now very simply put, a class is just an object that we can use to create other objects made up of functions and attributes. We'll create this class object here that we'll use to create other objects that we'll have to initialize using an instance. I'll talk through all of that right now because I know it sounds complicated. The first thing we need to do is to create the initializing function. We'll say def 2 underscores, which just means that this is a private function, initialize 2 underscores, parentheses, and now the first argument in your initialize function always has to be self. Now let's set a few attributes to our report class. Let's say that the report needs a title, so title, and it needs an author. We'll put a colon, and then for us to assign these, we need to say self, and then the attribute. So the attribute here is title and author, so self.title is equal to title. And then we'll do the same thing, self.author is equal to author. So what we've done so far is that whenever someone uses this class object to create their own object, when it initializes, we're setting these attributes. So now let's drop down and create a method, which is just a function inside of a class. We'll say def and then write report, parentheses, and this will take in self, and then it will also take in text. We'll put a colon and drop down. And now we want this to return to the terminal whenever someone uses it. So we'll type in return, parentheses, then we'll put curly brackets that we'll use for the title. We'll say by, and then more curly brackets that we'll use to format with the author. We'll say a new line, which we can do with the backslash and then an N. We'll put curly brackets, which will be the text here. And then we'll use dot format, which is just a function that we can use to format these blanks, and then we'll pass in what we want to fill in those blanks in these parentheses. So we'll say self.title, which is just this attribute right here, self.author, and then we'll put in text, which is just the function that we use right here. We'll save this and drop down. We'll decrease our indent all the way over, that way we're out of the class. And now let's use this class. And let's say that I'm the one writing the report. My report. And then we'll initialize the class by typing the class name, so report, and now we need to pass in the attributes of our report here. The title needs to be the first one, so let's say the title is I should have studied art, and then we'll pass in the second parameter, which is the author, which is me. So we'll type in Derek. So what this line is doing is creating a new object from the class object of report by initializing a new instance. Now that we have this initialized, we're able to use all the methods and all the attributes within the class. So we'll drop down and we'll say print, and then it's initialized here, my report. So we'll say my report dot write report as a function, which is just this method right here inside of our class object. And then we need to pass in the parameters of that function, which is just a text variable that we define here. So let's say this is object-oriented programming. We'll save the file. We'll open up a command prompt or a terminal and type in Python 3, and the name of my file is class.py. And we see that we've successfully used a method inside of a class object that we initialized here and then use the method of that class object here. The more practice that we get with class objects, the better we'll get. I hope this was a good baseline on how we can start using class objects in our Python scripts. I'll see you in the next video.